Hi everyone. Good evening. Are you able to hear me? Am I audible? Hello everyone. Yeah, anyone can confirm the same? Can you put in the chat? Am I audible to you guys? Akash is there. Komal is there. Andre is there. Rajat. Yep. Yes, right. Navneet. Music playing around there. So yeah. So all guys. So we'll have a first of all an interaction session. So these are right now, particularly in Bhubaneswar. From what all places actually you are attending this session. So first of all, I'll welcome, and this is system design zero to hero program, guys. This course, this is something new which you've seen me already. Structure and algorithm. Voice is breaking. Okay. Yeah, just give me a moment, guys. Yes. Hello. Is it fine now, guys? Is it fine now? I think this should be fine. Like now, this should be fine. Audio, please. Can you all mention in the chat? Can you all please confirm in the chat? Voice lagging, voice not audible. Okay, okay. Now it should be fine here. Still it is lagging. Okay, let me check. Yes, it's fine now, I guess. Fine, fine. Okay, okay. Yep. Okay. Sorry for that. I think there was some problem with the audio settings, might be. So, hello everyone. Once again, good 2.0 of Let's Upgrade and you guys. So, I'm here in Bhubaneswar. Places, from what all places you are actually. Fix it. Uh, mm, okay, Umang there, can you please confirm the same? Is my. Yep, it's fine. Persist. Is it fine now, guys? Is it fine now? Hello, hello, hello. Okay, still lagging. Why so? And this way, and I think hello. Am I audible now? I think so. It should be fine now. Hello, 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 hello. Okay, I am really sorry for this, but I think now. Okay, fine or not? Mm-hmm. Yes, yes, fine. Okay, and now I'm getting some positive responses, but again I'm getting some mix of responses. But audible, Trupati, Trupti, yeah, sorry. Yes, Shiva, it's fine. It's still Nishita says it's still an issue. Now, Mani says now audible. Yes. Umang, can you please confirm the same? Am I now perfectly audible? Okay, 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 okay. Let's finally begin this session. Very sorry, guys. Very sorry to all of you. I think there was some issue with the audio thing. I think now it's fine. I'm seeing good responses over here. It's now audible. Okay. So बीच बीच में आवाज नहीं आ रही. Okay, I think now it should not happen. I think now it should be fine. Okay, so now perfect. That's great. That's great. That's great. So good evening everyone. Hi again, and sorry for this audio issue or some technical issue. So very sorry for that. Anyway, let's move ahead, leaving those part apart. So hi everyone, good evening and welcome to Essentials 2.0 guys, and this is system design course we'll be doing today. And yep, I am in Odisha right now in Bhubaneswar and greeting you all a very good evening. Can you all please mention your places, guys? From what all places actually you are attending this session? So we are doing system design zero to hero course. Can you all please mention what all places you are belonging from? Maybe what place you are watching this session right now? Can you please mention in the chat? Okay, Mumbai. That's great. Nishit, Mumbai. Yeah, good evening, Prem. Good evening, Sayan. Sorry if I have misspelled that. Hyderabad. Okay, that's great. So Mumbai again, Hyderabad again. Okay, Karnataka. That's great. Hyderabad again, Chennai. So many of Hyderabad people. Okay, Manish is actually on a train. Okay, that's great. Ranchi, Kolhapur, Indore, Uttar Pradesh, Hyderabad again, Amravati, Mumbai, Karnataka, New Delhi, Hyderabad again, Maharashtra. That's great. Kurnool, Salem, Haryana, Nashik, Kolkata, Chennai. That's great. Andhra Pradesh, Ahmedabad. No, sorry, Ahmednagar. Okay, so we have people from like from every corner of this country. So I hope you would enjoy this session, and I will try my best, guys, to keep this session up. Some of you might already have seen me in data structure and algorithm session, but this time it's a different course. It's actually system design, and I think some of you have some idea about like where the system design is required. Okay, when you go for this interviews, Sometimes they ask some questions regarding the system design. Okay, majorly in the product based companies, they ask this question around system design. So I hope you would like focus in this session and take it the most out of it. Okay, before we actually start with the course, let me announce few important information so that you would be aware of how exactly this course should happen. So today is the day one, guys, and we have one more day, that is tomorrow, Sunday. The same time we'll do, you have to attend both the session and put your attendance. Okay, attendance link has been shared and it has also been pinned in the chat section, as you can all see it. Okay, so you have to put attendance for both this session. Also, I'll be giving an assignment or maybe a project. Okay, what I will see that you have to submit that. If you submit assignment and project, then you would be getting a completion certificate. Otherwise you will get it is like participation certificate. So we have two kinds of certificate this time. One is the participation certificate, maybe you can call it as attended the session, and one more is a completion certificate. So to get completion certificate, you have to actually submit the assignment project that would be given in this course. This is a 2-day course, guys. Today and tomorrow you have to attend both the session, put your attendance, submit assignment and project, get the completion certificate. That's it. That's how we are actually going forward in this course. And today it's basically will be knowing about the components and the basic description, the basics idea about the um, system design. And tomorrow we will try to implement those concepts. Okay, we'll try to build a project tomorrow. Okay, so tomorrow is actually a project kind of session and today is knowing about system design and get along with system design. That's what we would be doing. Yeah, I see also people from Odisha, Navi Mumbai, Nepal, Haryana, Howrah, West Bengal. Okay, welcome everyone, and let's begin this course. Actually, the toughest part from my side was to prepare the sequence, actually, in which sequence I'll go in system design. So I have listed down a sequence and which I am going to follow, actually, guys. So let's begin this. I will start with a question. I'll start with the question, and every detail, guys, every detail you'll find in the description. Okay, all the detail, how to submit the assignment, how to register. If you have not registered for the course, even you can register for it. All the necessary and important links are in the description of this video. You can check out it. Okay, or my team members are also putting in the chat in regular intervals. You can also fetch it. So let's begin without wasting any more time, actually. Okay, so yeah, lovely, and we'll go to that. We'll come to that. System design, compiler design, we'll come to that. It's basically different things. So once I explain what is system design, you will automatically understand how it is different from compiler design and all. So very first question, what is actually a system, guys? What is a system? System you see everywhere. Okay, everywhere, anywhere you go. So can you detect a problem, like what is a system design problem? I'll come to that, but first let's discuss what is actually a system. What is system? System, you can say, it consists of users, okay, and the components and the requirements. Okay, we have to fulfill some user requirements, so there would be some users would be there, and those users would have some requirements, and we would be using some component to fulfill their requirements. Okay, Sri Charan, again I say all the links are in the description, all the necessary links you can see after the session. You can again watch the session and go to the description. There is a link called assignment submission, how to submit assignment and all. You'll get everything over there. Okay, anyway, coming to this. So system consists of users, components and the requirements of the users. So we have a system. In the system, what we do, we use this various component to fulfill the requirement of users. That's a system. Okay, so what is design? Design is, see, there are various components to use. I'll come to that, what is component and all. I'll come to that, don't worry about it. Just go with the flow, guys. It might not make sense for the first time, but as we move forward and proceed, everything will fall into place. So what is design? Design is basically what is that? There are many components, so selecting the one component which would actually help us in this particular scenario. Okay, what we want, regarding our want, what component I want to pick up. selection of this component basically, and how they would communicate with each other, and how they would actually fulfill the user need. That is exactly the design, and this whole process is system design. Okay, selecting the components, various components for various purposes. Okay, so that all the user requirement would be fulfilled. That is exactly the system design. This whole process is system design. Why do we actually talk about system design? Why actually we are talking about system design? Let's take an example, guys. Let's take this very example of this YouTube, which you are watching right now. So what do you think about this YouTube, guys? How many users are there of YouTube? How many users are using YouTube? Can anyone guess? Can anyone put some a number in the chat? Asmiya, you can copy it, and please you can open in the different browser, or maybe one of my team can also check it out. Maybe why it is not clickable, they will find it out. Otherwise, you can just copy and paste in in a different tab browser, guys. That's fine. Okay, um, so yeah, my question was, this YouTube which you are writing, like which you are right now watching, what do you think? How many users YouTube has? Million or billion? Million or billion? 20 million? Nishit, are you sure? Like in India itself, we are billions. Okay, okay, 1.35 billion, right? India population. So there is China, then there is so many countries. I think there is no not a single person who doesn't watch YouTube. Maybe some kids and all, we can leave it out. Yeah, billions of people, we cannot maybe say exact number, but yes, billions of people are actually users there in YouTube. Okay, and if you see, at this moment, if I say at this moment, at this particular second when I am saying this, what do you think? How many users are actually seeing, watching anything in the YouTube? Anything right now? Some billions again, right? Maybe millions, or maybe billion. Maybe there are total 10 billion users, and right now at this particular moment we have, let's say, 50 million people who are actually watching something or other thing in on the YouTube right now. Okay, so if at a particular second 50 million people are watching something on YouTube, and YouTube is able to provide service to them, how actually this happens, how YouTube is able to provide the services to so many users at a particular time. That is all about system design, guys. Okay, that is all about system design. We have to actually estimate the capacity, and we have to provide service to all the users. Okay, we don't want our system to crash. You might have seen this when your results get out, or a release or something. Okay, so many students at once they try to fetch their result, and the server goes down, and you are not able, like the web page doesn't open. Okay, might be there is a chance that they have not actually designed the entire software, that web page properly. System design, before actually developing a software, before actually making a product, we should be properly designing the system. So system design is all about seeing the scalability actually. Okay, designing scalable products, you can say. Okay, if your product is aimed at serving millions and billions, then system design is what you should be actually good at. Okay, you need to think beforehand. Okay, my product is today it's 5,000 users, but down the lane, maybe 2 years or 3 years ahead, there would be 10 lakhs of people. How can I actually require, like, service them their requirements? How can I fulfill their requirement? That's what is all about system design, guys. There are a few things which I want to cover. First of all, so I've listed down here like in a sequence. I don't want to miss out anything, so I will also refer the sequence what I mentioned. Okay, there are a few things which you need to take care. First and foremost thing, let me go to this whiteboard. I want to write something actually. So anyone here? Okay, my bad. I'm able to write or not? Why it is not working? Oh, it's. I hope you are able to see the whiteboard, guys. Everyone. I hope everyone is able to see the whiteboard. I'm right. I'm trying to write something, but it's happening. Okay. Anyway, what I'll do is I'll open maybe a WordPad or something, and I'll write down there. Maybe I'll just open a PPT, guys, and that would be better for us. PowerPoint. Yeah, don't worry. I'll be sharing the PowerPoint also with you. Just give me a moment. I'm just opening it. Yeah, coming to the let it open. Meanwhile, we'll have a discussion. How many of you know this? How many of you actually have heard about functional and non-functional requirement? Can anyone please mention in the chat? Do you know this functional and non-functional requirement? Have you heard about this? Some of you might be doing the BTechs or maybe MC or BCA. There was some subject like this software engineering. Have you studied that software engineering? In that we have actually studied something called this functional and non-functional requirement. Obviously there are a lot of other things which we need to know while actually designing a software, while we are actually aiming to design software. But right now I don't want to actually get into the depth of this, but we need to have the fundamental and basic idea about it. So I'm just asking, how many of you have heard about this functional and non-functional requirement? No, no one. Sakti says yes. Those who know it, those who actually have heard it, can you give any one example, guys? What do you mean by this functional requirement? What do you mean by this non-functional requirement? Can anyone differentiate here? And meanwhile, like I have, yeah. So I have opened the PowerPoint. So I'll be sharing with you quickly. Okay. Yeah, meanwhile, guys, you please answer what is those who know it. What is functional and non-functional requirement? Can you mention it? Can you mention it, guys? Please put your answers there. And what I'll do is I will share you with a different thing. I think my writing pad is not working right now. So I'll use this PowerPoint for our purpose. Okay, right? Okay, why it is not? Okay. Yep, I got it now. Yeah, I hope now everyone is able to see this PowerPoint. So no, Ankit, actually, see, the data science algorithm is one part of when you go to an interview in a product-based company, data science algorithm is one part and system design is another part. Okay, both are different. There is I won't say that you need to know data science DSA before learning data system design, not at all. DSA is all about like implementing your and optimizing the problem, how efficiently you do a problem. System design is a high-level design thing. Okay, before you actually want to design something or create a product, create a software, you want to develop a best software. So for that we actually have to design it first. Like I was saying, how YouTube is actually handling so many requests, how it is able to service so many people. Uber, think about Uber, guys. Uber, how it is able to book a ride for you. Like so many users would be there and so many would be booking at the same time. How it is able to provide service. Okay, think about any such thing, any application right now, any big application, maybe Google search. Okay, you may think about this Bitly. Okay, you may think about WhatsApp, anything, how it is actually able to handle so many requests. Okay, when I say request, actually users request, user are sending messages or reading messages, so those are all requests, right? So how it is actually handling, how it is able to handle so many requests. Okay, I'll talk about it. It would make sense everything, just give me a moment. So first we are talking about this functional requirement, functional and non-functional requirement. So functional and non-functional requirements, so it's very simple, guys. You go to any, let's say you go to an institute, or maybe, yeah, talk about, let's say let's upgrade you. What is your expectation at let's upgrade? Yeah, even Zomato, yes, Zomato, yeah. So how it is able to get your orders, and so and so provide service. Okay. Hmm. So just think about let's upgrade. What are the functional requirement would be? It is more about, it is more from the user's perspective, guys. Functional requirement is what do you expect from let's upgrade? You come and you get a course, complete it, finish it, and you just get a certificate. You get a certificate and take learnings out of it. That is your functional. That is the functional requirement of the let's upgrade product. If I say let's upgrade is a software product, though, so the functional requirement would be something which the users would get, you, what you are expecting, what you are getting actually. Okay, you are getting courses for free, and getting certificate out of it and learning something out of it. That's the functional requirement. What are non-functional requirement? So I can simply say, putting forward, to fulfill those functional requirement, what are the things we need in the backend, in the background, those are called non-functional requirement. Let's say I need a streaming software right now, which I am using a Streamlabs right now, so I need that, or I need that, so that becomes a functional non-functional, sorry, non-functional requirement. I need an LMS. Okay, that becomes a non-functional requirement. For LMS, I need I need a server, I need databases so that I can store your data there, and give you, like, if I don't store your data, how would I send you informations? I need your mail ID at least, right? To, so that I can provide you informations. We need to add to a community, and also there will be various things. So non-functional requirement are something which are which combine together and try to fulfill the functional requirement. Okay, right? So I guess I hope you are clear, guys. Let's say you go to what is that? Theater, cinema hall, theater. What is the functional requirement? You go there, you watch movie, come back. Okay, but for that, for you to watch the movie, what are the non-functional requirement? It should have sound system, it should have proper seats, and the screen should be good, and those are, there should be a screen, projector screen and all. Those are non-functional requirement. I think it's very clear now what is functional requirement and what is non-functional requirement. Is it clear, guys? Everyone clear? Everyone? Yes. Okay, so functional is something the user needs, non-functional is something which are required by the software side team, you can say, to fulfill those functional requirement. Okay, so that is functional and non-functional requirement. Prem, you want me to repeat non-functional? I think it's pretty much clear to everyone right now. I have already repeated. So let me know, guys. I'll be coming back to your chat again. Let me move forward. If you don't understand, again, I'll explain what is functional and non-functional requirement. So in the next list, I have this basically what we do in system design actually. As I said, there are various component. There are various component, but we have to select the best component. Let's say, let's talk about this this chair where I'm sitting. Okay, so in order that you have to, you are here in YouTube, and you want to learn this system design from Let's Upgrade, you are there, but the to fulfill that, I need this streaming software, I need my laptop, I need this streaming software, I need a chair to sit. Okay, so I will say this chair is not good. Okay, I need some more comfortability so that I can give my best. Or this laptop is not good, I need a better laptop where I have this good RAM, good graphics and all. Okay, so selecting the one, So every component will have its pros and cons, guys. Okay, you have to compromise, and there will be some trade-off. There will be some trade-off. That is all about system design actually. Every, like, if you go to different company for a particular problem, there would be different solution actually, because one company would be ready to compromise something and the other company would not be ready to compromise that thing. Okay, do you understand? So system design is not about a, like, there is a single solution to a problem. No, there will be maybe three, four, five, six solutions, but as per the company's requirement, they would select one of that. Every component has its own pros and cons. What the company is able to compromise, you need to make a trade-off there. Manish, you can fill it after the class also, not an issue. I hope you understood what exactly we're doing or we are going to do in the system design. So there are multiple option, guys, as component, but you have to select, like, there would be pros and cons of every component. But like, what can I say? I need a better chair, comfortable, but if I go for comfortable chair, then it would cost more, obviously. But this chair or maybe other chair, that might cost less, but that might not be very comfortable. So I need to like do the trade-off, compromise here. I can, if I'm ready to pay more price, then I can go for the comfortable chair. If I'll say no, I cannot, I don't want to pay more price, I'll adjust somehow. So that is what I'll go with this chair. So in system design, every component will have pros and cons, guys. You have to select based on what you can do, the, like, how you can do the trade-off. Okay, what the company is ready to trade off, what the company is ready to compromise. Okay, for example, let's say, what example I'll say. Okay, let's talk about this databases, or maybe, so not databases, something something other. SDLC is a part of this. Yes, Manish, you can say software design life cycle. So it is more of related to software engineering. System design, in system design, I'll not touch this SDLC part. I would be more focused on the design part. I'll not go to this SDLC right now. I'm in a different track right now. You'll get it, like, where I am going. So I hope you understood, guys, this under this pros and cons, what I am doing to I'm trying to do, the where I need to compromise between different component. There would be n number of options. Okay, how many have heard this SQL and NoSQL? We have databases, SQL databases, we have also NoSQL databases. Let's go to this data, let's go to this database examples. So we have both SQL database option and NoSQL database option, right? Have you heard about this? I think you might have heard about this. We have MySQL, we have Oracle, we have MongoDB, we have DynamoDB, we have what else? There are lots of databases, right? So what we'll do, for our purpose, for our product, which database would be better? That you need to select. That you need to decide. Maybe that would have some like demerit, but you are ready, if you are ready to compromise with that, then it's fine and good. Every component, every solution has its own demerit, guys. The thing is, with which you want to, like, you want to do the trade-off and you can compromise, and we'll go with that. So you can say simply, every person may come up with different solution for a particular problem, and and the solution accepted by different company can be different, because that depends on them, what they are actually willing to compromise with. Yes, Swagata, PostgreSQL is also SQL database based on SQL. Yes, so that's what. So we have to select. We'll go with SQL database or we'll go with NoSQL database. That's completely like on the type of product we are designing. Also the limitation with the company's trade-off. Okay, so that's what we are doing. So this is the point which I had to cover. Let's now actually finally go to this component of system design. Okay, so I will say here, we can say that, okay, we have logical components, and we can say physical components. Okay, logical components and physical components. We have two kind of component. It's not very you can say, we don't use these terms normally, but that's fine, I guess we can understand. What are the logical components? Examples: if we see what are logical components, so you can say data, logical components, databases, logical components, and maybe you can go with many other things, guys, many other things. Okay, like maybe applications, maybe what is that, cache. Okay, these are also component, these are, everyone is component. I think you all have heard about cache. We'll be coming to that. I have included that in today's discussion. I'll come to this cache. We have see maybe network protocols, I can say, as a component. Okay, so there are many things we have to discuss. Maybe there are load balancers, even this we will come to this. I'll discuss them in detail, guys, you don't have to worry about it. What are this actually? So data is, you can say, a logical component. What are actually the component? Actually the data can be, you can say, text or images or maybe videos or maybe some other data. Okay, so these are actually the physical components, you can say, the technology, you can say, or maybe yeah, that's what we really store. Databases is a logical component. What actual, like one of you said, PostgreSQL, yes, it's a physical component. PostgreSQL, MySQL, maybe Oracle, maybe MongoDB. Okay, many things are there. DynamoDB. You can go with anyone, guys. Postgre, MySQL, MongoDB. So these are the physical databases. Like applications, you can go for Java application, you can go for Python application, you can go for React application. So even, and cache, yes, cache also there are many options we have. Like we have Redis cache, we have Memcache. Okay, network protocols, there are various protocols. Again, we have this HTTP, we have this REST. Okay, then we have this WebSocket, we have TCP, UDP. Okay, there are many protocols, so we can go with any one. Load balancers, there are also examples of load balancers, like we have traffic, we have what is that, I don't exactly remember those names. Yeah, traffic is one of them, I remember. And I think HA something is there. You can check it out, guys, what are the different load balancers are there. I'll come to this load balancers and all. Okay, not UX design, not UX design, it's not UX design, it's about actually building a product. How can you serve users? Okay, right? So fine, so this so I guess now it is very clear what are logical components and what are actually physical component. So data is the logical component. Text, images, videos, which are actually datas, or I can say, I should say only data, they're actually the physical component. Like database is a logical component. This Postgre, MySQL, MongoDB, these are physical component. So likewise application, you can go for maybe React app, maybe Java app, maybe Python app, whatever. Okay, these are, so this is basically logical and physical component. Okay, so these are all component, guys. And the next thing which I want to discuss here is, so I want to discuss here is something which I think you already know, you might have heard a lot about it. So what I'll do is I'll just go to the next slide. Yeah, so here, see guys, there is a application, this is a application one, let's say, and there is another application. See, I'm actually okay. What I'll do is I'll actually show you how system designs are done. Okay, directly. So on live. I think that would be a better process through which we can learn. So I'll be actually inserting some shapes here. Okay. Now you'll understand how system designs are done. It's actually system designs are done this way, guys. So we create some blocks. Okay. So okay, I'll just copy it. Fine, I have another here, and I want to write here something. So what we have to do, I think a text box will work. Okay, so this is application one, and I think I should copy this and I should delete this. Okay, have I copied the text box? I don't think. So yeah, so application 2, let's say. So I have two applications, application 1 and application 2, and I need to get some data. Application 2 wants to get some data from application 1. I hope everyone is following, guys. I'm doing it live here in front of you, how exactly we go for a system design. But it is not actually system design what I am right now. I'm just taking out a very small portion of it, and I am trying to explain you something here. So we understood functional non-functional requirement, we understood what are components actually. Now we are trying to see how actually this communication happens between um different component. Okay, right? So see this. So what I'll do is I'll go with this. So application 2 actually need to communicate with application 1. It needs some data, let's say, from application 1. Application 1 is a different program, I would say. Let's say it's a different piece of code, it's a different program. And application 2 is a different program. Maybe application 1 would be a Java program and application 2 is a Python program. And Python wants some data from this Java application. Python application wants some data from Java application. So this thing cannot be done directly, guys. That is a catch here. This cannot be done directly. So what we'll do, in between this there would be like something else. We have to come up with something else. What is that else? This is nothing but okay, API. Have you heard about API? I think everyone knows and everyone has heard about this API, at least everyone. This is a very common term nowadays. So I think everyone has heard about this. Okay, I'll just close this part. Tips and one more. And API communicates actually with this application, right? And then application 1, this Java application, will return back the data to API, and then this API will return back the data to application 2. This is how it is done. Okay, right? Yes. So if I have a Python application and I want to communicate, I want some data from Java application, they won't communicate directly. There should be something in between them, that is called as API, application programming interface. Yes, Sneha, yes, you are correct. Okay, application programming interface, that acts a mediator between these two kind of application. So application 2 will communicate with API. API will go and communicate with the application 1 and will fetch the data for application 2. That's what API does. Okay, right? Yeah, you can go for any like REST API or SOAP API. Yes, Sudhir, you can go for that REST API or SOAP API. I'll not go to this REST API to be very honest. I'm just telling you something how actually the data transfer happens in the background. Okay, if you have two applications, so we go through this way. We go through API to fetch data from another application. Okay, there are different things here. From this very simple example, actually. I would move ahead to architecture which is known as client server architecture, guys. Okay, here application 2 is a client and application 1, you can say, is a server. So we are basically now trying to talk about client service architecture. That's a very important architecture, guys. So let's go for that. Why actually I'm not scribbling and I'm picking up this PPT. I want to make this clean designs, so it's better if you create these blocks and keep it very clean. System design, in system design, it is expected from you that you make clean design so that you don't confuse yourself at a later moment. Okay, right? So we'll talk about client server architecture in a very short while. But before that, I want to discuss something about which I just mentioned a few moments back. I was mentioning, and that is nothing but scaling. Okay, I was mentioning, right, system design is all about not creating exactly, designing a product which can provide services to very large of people. So what is the scaling? What is the scalability? Scalability is if your system is actually helping out or maybe providing service to 100 people, then maybe at a later stage it should be able to help 1,000 people. That is scalable product, right? That is what we know what is scalable product. That is what is a scalable product. Okay, if now your system is able to handle 5,000 people, if at a later moment, maybe next moment, if there are 5,000 maybe 10,000 requests, your product or your server, you can say, should be able to provide them service. That is a scalable product, and that is how are talking about, that is why we are talking about scaling here. Okay, so scaling, guys, scaling is nothing, very simple. Okay, so your system, or yeah, your system should be able to provide service. If it is able to provide service to 100 people, then it should be able to provide service to 10,000 people. Okay, if the number of user base scales up, obviously, if I am a designer, if I'm a developer, if I'm a company, I'm designing a product, I would want that more and more people should use my product. And to be able, then the people, if they to be able to use the product, your product should be scalable. If your product is not able to serve them, what is the use of it? What is the use of this aiming so high? It's very simple. If you design a small little you if you design a mobile app, let's say you have developed a small mobile app. Okay, you would want, right, millions people will download that and would use that. But let's say your application, whatever you have built, is not scalable. So if like a million of people start sending requests at once, your system is crashing down. Obviously they would leave, they would not use your product anymore. That's what we don't want. That is why we are doing system design. Okay, so we'll come to, like, we'll go to this many things actually, guys, later on. But right now we are talking about the scaling. Very specifically, we understood what is scaling actually. Scaling up. Okay, scaling up we are talking about. So what is scalability, we understood. And let's talk about, like, what are the different types of scaling actually. So specifically we have two kinds of scaling up. One is vertical scaling. What we can do vertical scaling, and we can do horizontal scaling. You say horizontal or horizontal, your wish. So vertical scaling and horizontal scaling. So what is the difference actually between this vertical scaling and horizontal scaling? Let's now understand this. Okay, if my team members are there in this chat, even they would actually relate it. Scalability is a non-functional requirement. You can say in a way, Swagata, you can say in a way, yes, if your product is not scalable, then it won't be able to okay, not exactly, you can say the non-functional requirement is more about the components you are using actually. Those are non-functional requirement. It's more of a capacity estimation, you can say. Okay, capacity estimation of a system, that is what we are doing. First, in order to design a system, if you want to design a product, you want to develop a product, so you have to understand first two things, that is functional, what is the functional requirement of the problem, and what is the non-functional requirement. Okay, non-functional requirement you cannot say actually scaling up. So functional requirement, we understood the requirement, basically the what the user expect or what we want our users to get. And to give those features to our users, what are the technologies we need, or what are the components we need, those are non-functional requirement. And the third point here is capacity estimation. Capacity estimation is how much users our system would be able to actually serve at a moment, at a particular moment. Okay, at a particular moment, like I've heard a lot of people complain about this IRCTC website, right? Like every time it is down and it don't serves better way. Maybe maybe the system design is poor there. Okay, so scaling is something about, it's related to capacity estimation. How much what is the capacity of a system, how much user it can serve at a particular point of time. Okay, if your user base is very large, how can you actually increase the capacity, how can you actually scale up? Okay, scaling up is nothing but you even if your user base increases, you should be able to provide them service, your system should not crash. That is scaling. There are two ways of scaling, guys: vertical scaling or horizontal scaling. I think my team members are also there in the chat, so I think this thing is also new for them, and they can also better relate this vertical scaling and horizontal scaling. I'll take a very real life scenario, guys. Let's say in a particular organization, okay, earlier there was 5 tasks to do. Okay, there were 5 tasks to do, and we had, let's say, 3 resources in the sense 3 team members. We had 5 tasks, or maybe I'll just make it 6, that's better. We had 6 tasks to do, and we had 3 resources. Okay, right? This is the like, yeah, given situation, it is there. Now our task now would increase to, let's say, 12. Right now, let's say the number of tasks was 6, but now the task has increased to 12 tasks. I have still those 3 resources, so okay, still have 3 resources. So each resource had how many tasks to do earlier? 2 tasks to do. 2 tasks. But when this scaled up, now it came like 12 tasks to do. So what I can do, I can distribute this more 6 tasks among these 3 resources. Okay, so each resource will have now how many tasks? Obviously 4 tasks. 3 4s are 12. Earlier they were having 2 tasks only, but now they have to do 4 tasks. This is vertical scaling, guys. This is vertical scaling. Okay, if you are increasing capacity of the existing resource, that is vertical scaling. Understood vertical scaling, everyone? Can you please mention in the chat? Can you please respond in the chat? Did you understand what is vertical scaling? If number of tasks increases, okay, if number of tasks increases and I have the same number of resource, if I increase the capacity of each resource, that is called vertical scaling. Okay, you can also think of this way. You have seen this Sholay movie, right? Sholay movie. So there is a bike and there is additional we can say a seat or something, can say. Okay, in that bike, let's say nowadays many, like, so many bikes are coming, only one person can sit, one person can sit. So earlier it was like only one person can sit. So if you want to have one more like person to sit, so what you will do, we'll just increase the seat, one more, like you'll renovate it, or maybe you will do some modification there. Okay, it's very simple, like okay, let's give me another example that would be more relatable to you. You are in a classroom, there is only 4 bench. Okay, and there are maybe 20 people are there, so each bench will get 5 people. Okay, right? Okay, that is very large. 4 benches are there, let's say we'll go for 12 people, so each bench can accommodate 3 people. So not can accommodate, but 3 people will be seated there in 4 benches, that makes 12 people. Now let's say yeah, 16 total. Now 16 people are there total. You have still the 4 benches, right? So what you will do, you will make 4 people sit in each of the bench. That is horizontal, sorry, that is vertical scaling. This is vertical scaling, guys. Got it? Okay, all right. System design needs any coding? No, Mukesh, it's not about coding. It's a high level design. So when you go to low level design, then you need coding. Here there is absolutely no need of coding actually. System design does not involve coding. It's a high level design. Okay, you need to understand the system before coding. This is required before you go to code. If you don't know what component you are going to use, how would you code? Whether you use Java, whether you would use Python, whether you would use MySQL, whether you would MongoDB. If you don't know, first of all, how would you code? So this is pre-coding stage. This is actually the designing phase, right? Okay, so this is vertical scaling, guys. If you have resources already, if you are adding to their task, if you are increasing their capacity, that is horizontal, that is vertical scaling. What is horizontal scaling? Horizontal scaling is, instead of adding this task, okay, to them, these 3 resource, what we will do is we'll bring more 3 resource. Okay, I'll bring 3 more resources, and my team member will relate this because we just had discussion on this today itself. Okay, right? So we'll add 3 more resources. So 3 plus 3, now we have 6 resources. So each resource will still have 2 tasks to do. This is horizontal scaling. Yeah, I'm going with basics, Jai Prakash. I'm actually going with the very basics. We haven't actually jumped into the system design. We are actually learning the basic, the prerequisite, which you should be aware of the things. Okay, so understood this, guys? What is vertical scaling? What is horizontal scaling? Vertical scaling is if you increase the capacity of the existing resource. Horizontal scaling is if you increase the resources. If your task increases, then you increase the resource. Every resource will have the same load, same load. The load will not increase on on those resources. That is your uh, horizontal scaling. Clear? Clear, everyone? Clear? Please confirm the same on the chat. So this you can also relate to a database, guys. Okay, so if you want to have more data in a database, you can increase the size of the database. That would grow. That is vertical scaling. Okay, but vertical scaling, the problem is if the data grows very much, so much, then the database will not be able to handle so much of data. So in that case, what we'll do, you'll add one more database, one more database, right? Okay, so I don't know whether I can create it very fast. So shapes, I'll go and okay, okay, I'll use this. Let's say this is a database. This is a database. DB, I'll just write. So we have one database, right? So we'll have many datas here. Okay, many data. I'll just write something, blah 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 blah. Okay, if I want more data to be stored, what I'll do is I'll increase the size of this database, and I'll store more data. This is vertical scaling, but this will not help you a lot. Not always it will help, because if the data grows, like go on increasing and it becomes so huge, at a certain point of time, this database won't be able to handle those many requests, or it will not be able to handle those load. So what we can do here is we'll say, okay, just bring one more database, and we don't have actually have to increase the size of it, go on increasing, and the load would be distributed. This is horizontal scaling. It is very actually you can say very we can understand by seeing this. Horizontally, I'm adding one more resources. I'm adding resources parallelly. So this is horizontal scaling. Vertical scaling is you just increase the capacity of the existing resource. I hope this is very clear to everyone, because I'm going to the next thing, which I have mentioned a few moment back, that is client server architecture, guys. I hope it's clear to everyone. Please mention in the chat. Are you with me, everyone? So let's see. Are you all with me? Okay. Why this is not working for me? Uh, fine, fine. Scaling. I'm just creating a poll, guys, for you all, so that I need to know if you understood this vertical and horizontal scaling or not. Yeah, please, can you all answer the same in the chat? I have raised a poll. Okay, 100% yes. That's great. That's great. Okay, 16 votes I have got. Maybe you can vote. Rest of the people also can vote. Anyway, fine. So yeah, so horizontal and vertical scaling is done. Let's go to our client server architecture, guys. Okay, let's go to our client server architecture. Okay, I'll add this. This would be sent. Actually, what I'm doing, guys, I have not formatted anything. So what I'll do is I'll just send this as materials. You'll be getting this as materials in the community. I hope you have checked the community link is given in the description, guys. So I'll send this PPT, this presentation, as a material in the community. You can watch it, you can have it later. Okay. System design, see Priyanka, system design, as I said already, in product based companies, when you go along with this DSA, they also go for this system design. They want to check your analytical skills. Are you able to actually design before, like what are the prerequisites while going for a design of a product? Actually, can you think, can you have a foresight what would happen if so many users will come? What should be like my product should be able to serve them? So that is what they check. And mostly if you go for like Google, Microsoft, this FANG, okay, FANG companies, and if you go for an SD2 level a job, then definitely system design is one of the question. Like system design would be definitely a question. They will ask you question from system design. Okay, fine. Let's go to client server architecture without any more delay. So, yep, I'll just create one more slide over here. So, we are talking about client server architecture. Yeah, architecture. I hope the spelling is correct. Client server architecture. So, in every communication, there would be a client and there would be a server. Fine. Okay, client, so we understand what is this client server. Client will request a data and server will provide data. That's what. Simple, very simple. Client will request a data and server will provide the data. So I'll just create some building blocks over here. Whatever I'm creating, these are called building blocks, diagram, you can say. Building I'm drawing the building blocks actually. So here again I'll be creating actually two. I have this client and I can just copy and paste, and this is server. Okay, so what I'll do is text box, this is client, and text box, this is server. So this is our client server architecture. So client will this client will request some data, request something, let's say, okay, and server will provide that. Okay, so how server will provide, that is another problem, not problem, basically how server will give back the data as required by client. Maybe see, it's very simple. You want to see your profile, maybe in LetsUpgrade account, you go to www.letsupgrade.in and you go to your profile section and you see you will see your details, right? So that means server has your details there. Okay, server has the detail. So I would have here the respective data. So server has the data with it. Okay, one more thing the server can have, that is actually I'll say that is logic. Okay, what is this logic? And I'll just yeah, data and logic, both this part would be there. What is data, what is logic? Data is any data, like maybe your profile, your details, maybe those are data. What is this logic? Logic, you can say computational logic, or you can say some programs also, you can say, maybe some programs you can say. So what do I write this program? Maybe you are giving some value to the server and you need your server to return answer. Okay, take any value, no? Take anything. Maybe you just want what is the square of 4, so you just send 4 to your server and server will calculate what is the square of 4. So there should be some logic inside stored in the server. It will just apply that logic and will return back the value of 4 square, that is 16. Okay, right? Yes, Sujit, yes, you are correct. So that is your logic or program, that I can say. I better we convert it to logic. Program doesn't make sense over here. Better it is logic. Yeah. So a server can have data and logic based on which it actually serves the client. So a browser, here you are watching from YouTube, right? From obviously a browser, you are using a browser. So that browser, your browser is a client, and YouTube, you can say, is a server. YouTube will have a server somewhere, and it is actually sending you the data and you are seeing it. There are a lot many things involved, but just to keep it very simple, I'm not actually I'm not doing it complicated. So your browser is a client, you are a user, very user, and your browser is a client. Your client is also a system, guys. Okay, so you would be user here. Okay, okay, I'll just go with this. So this is you, this is user. Okay, and maybe I will just insert one more shape. uh, uh, okay, I'll just go with this one again. This is one more person is there. Okay, both are user actually, but the thing is, this is user, or the not here, white text box. Oh, I think I have to write on the top of it, I bet. So this is user, that is you, right? And this is the admin, server admin. Okay, so both are person only, users, but the role, the responsibility is different. Admin responsibility would be different, and user responsibility is nothing but you just want to get some data, you want to fetch some data from the client. So user will interact actually. User needs something, so it will interact with the client. Okay, right? Then client will request server, and yeah, server would have it stored, server would have this data and logic stored, and finally it will just return back the data, the required data by the user. That's what this is, a client server, simple client server architecture. I think those who have studied this web development or something, they might have they might have learned in the very first class, the client server architecture. So I just want to break it down into a simple thing. I don't want to get into web development or something. Okay. Yes, Arapalli, yes, exactly. The server should have knowledge how to do the task. Okay, so it contains both data and logic. So that it can provide your data. See, sometimes client needs only data. Sometimes client needs, like client will give something, send something to the server, and want server to compute, do some operation on it and return back. But sometimes client will just request something, server has to use the stored data, compute something on it, perform some logic, and then return the result. Okay, so both can be used, or any one of them can be used at a time. Server can use any one of them, or maybe both of them, for a completion of a particular request, right? So this is client server architecture. I hope everyone understood what is client server architecture. I want to discuss a few more things based on this client server architecture actually. Okay, I just want to just create a new slide. It's a continuation of clients of architecture, guys. I want to discuss something called a thick client, and there is something called thin client. Have you heard about this term? This is something new. I think we haven't done at Let's Upgrade yet, this kind of thing. So client and server, we know client requests for something and server provides the required serves the request from the client. That's what we know, this client server. There is something called thick client and thin client. Okay, what is that? Let's understand what is thick and what is thin client. For that, what I'll do is I'll just duplicate this and just take this. Yeah. See guys, if this data, if this data and logic are with client, then this is known as thick client. I'm just changing the name. Okay, this is, oh my bad, thick client. This is thick client. If client has the data and logic, at some places client will have this data and logic. It will just request the server, and server will just it has to do lots of process on the client side only, but it will just request server, and server will help client to use the data stored and logic, use it. Okay. No, no, not exactly, not exactly. uh, Neha says that means server can perform as interface between the client and data. Yeah, that's what. Isn't it? Isn't server is doing the same thing? We are actually requesting server, okay, and server actually fetches data from databases. So yeah, we can say it's actually kind of interface or something. But yeah, we should not actually say a server is an interface between client and the database. But yes, if you see, it's kind of same thing. Okay, so here client has the data and logic with it. Server just helps client to use this data and logic and produce the result. Some example, I can say, let's say my streaming software. Okay, data I have here. No, I think this would be okay. Let's go for a game, na, offline game, let's say. Okay, maybe some online game also. So all the data and all would be processed at the client side. Your system, your computer has to process the visuals, the graphics and all, everything, the images, pictures, everything has to process by your system. That your system is client, server is somewhere else. Okay, server is just updating everything. So that is an example of thick client, where the processing happens at the client side and not the server side. Okay, yes, yeah, Sujit, exactly. So browser, so asks server, and server fetches the data from database. Okay, we'll come to that point again later. Like not later, not much later. I'll just discuss that in a few moments. Okay, so if client has the data and logic, if the processing happens at client side, then it is thick client. But if the same thing happens at the server side, basically this one which we had already discussed, this actually is thin client. So I'll just copy it, and I'll just rename it. It is actually an example of thin client. So this is thin client, and the previous one, this is thick client. What happens in thick client? The processing and all happens at client side. Okay, and in thin client, processing and all happens at the server side, which we normally tend to understand this. Okay, many online games are there, guys. You can say that is actually thick client. They follow this thick client concept. PDF, yeah, PDF converter also, yes, yes. Okay, PDF converter. You can also, because the processing happens at in your phone. PDF converter. If you install an application in your phone, so that converts your document maybe into PDF or something. So that is a thick client. Example of thick client. Yes, actually, very good, Chakradhar. Okay, that's a very good example of thick client. This is thick client. Thin client is something where if the processing happens on the server side. I hope it's clear to all of you. Thick client and thin client. Okay, fine. Okay. So, anyone could not follow what is thick and what is thin client? I see some people have not understood this horizontal and vertical scaling. Okay, I'll maybe towards the end of the class, I would again explain that. No, it's not an issue. Clear, guys? Thick client, thin client. I'll be moving forward to the next thing. I'll be discussing this tiers of actually this clients of architecture: two tier, three tier architecture, n tier architecture. Okay. So please just confirm me once if it is clear to you what is thin client and thick client, and so that I would proceed further. It's not actually really a like coding or something would be like hard coding or something would be doing it, implementing something. It's more about visualizing the process and understanding what happens there before we actually develop a software. the pre developer development stage, you can say. Understood, right, everyone? Okay, okay, that's great. So now let's talk about this two tier, three tier, n tier so client server architecture. See, sometimes what happens, server cannot itself contain the data and logic. Not always. Okay, server has its own limitation, right? Server, how much big the server would be. So what is server? Server is also a machine. Like client is also a machine, server is also a machine. So if it is a machine, then it would have its limitation, right? Okay. So every time it cannot happen that server will contain all the data and the logic. Okay. So what happens there in those cases? So they would be segregated in a different manner. Whatever we discuss, this one, this or this, whatever you think, this is a two tier example of two tier architecture where server has its data and logic with them. We are just, these are two component, client and server, that's it. This is two tier. But if you look for actual the real time products and all applications, this may not be very feasible, because when we say data, then there will be a lot of data. Even if you go for let's upgrade server, there would be a lakhs of data about your students, right? Stored, the email id, maybe name and all, and which course they have enrolled into, right? Okay. So it is not possible to store every data in the server, so we need to break out them. This is two tier architecture. Okay, what I'll do is I'll just copy this again, I'll paste it again, and now my topic of discussion is tires. This is actually two tier architecture, right? What about three tier architecture? What is that? So let's see this. What is that? So I would be deleting some, and also I'll be deleting this stuff, guys. I don't need, actually I don't want to complicate things. I'll just delete, delete. I don't need, even I don't need this, delete. Yeah. So now server cannot contain all the data and logic. So logic might be here, and there would be another thing where the data would be stored. Okay, so this data unit and logic unit are separated. This is three tier architecture, example of three tier architecture. Okay, this data you can think of database. Okay, you can say it is a database, this data part. Okay, you can say that this is a database. Okay, so I will just I am not able to actually create a, I think it doesn't allow here to put. Okay, anyway, fine, I think you understand. I'll just write in a maybe in parenthesis, I'll write this as, you can think it as of a database. Okay, and logic, you can say this is your service. Okay, service, maybe some application running on. Okay, I will basically call it as a service. Yeah, let's get rid of this logic term and better we go for service term. Okay, service name, any particular application. In short, you can say it is an application, right? So now the logic and the data are separated. This is three tier architecture, guys. Okay, when the logic and the data part are separated. Okay, now what about entire architecture? What is entire? You can also think of this as a server. Someone was saying, right, this you can treat it as server. Server is also a code, right, piece of code running on a machine. So that is an application server, okay, which would provide us some service, and it is fetching data from this database. So that is a three tier architecture. Okay, but when you go for a large scale product, maybe Google, maybe YouTube, maybe Uber, maybe Amazon. Okay, if you go for those product because it has a very large user base, then having only these 3 tiers will not suffice whatever you say. In that case, so many other components get added. Okay, so what I'll do here is I'll just copy this thing and I'll add some more component. Like, what are the other component? See guys, when there are large set of data, and and you don't want to overload your database, also you need some faster access of data. So in between this database and this your and this application, there would come another block, actually another component, and that component is nothing but cache, you can say cache. I say cache. Okay, so there would be cache here. Okay, so client, so and between this service or this application and database, there will be a cache. Okay, how many of you know what is a cache or cache, and why it is used for? If you have studied this architecture or something or operating system, you might know, you might have heard this term. Even your browser, it says, right, there is something called cache or something. So what is the use of cache, guys? Cache, whatever you say. What is cache? What is cache memory? It is kind of a memory, actually, you can say. What is this cache? Why do we use this cache? Anyone? I expect some answer from at least one of you. And to be very honest, I have given already an answer for this. Like, we don't want to overload the database. Also, we also want to fetch data bit faster. So there is where we come bring out this cache memory. It's fast, yes, it's faster than the database thing. Okay, cache is something. There are, you can say, okay, let me give this example. Have you ever experienced this? You go to a new website. First time, that website will load very slow, and furthermore, the coming like when you open that website next time, it would open up quickly, very fast. Have you experienced this? Let's say you have like typed a new website, you have just typed a URL for a new website link. It would load maybe slower for the first time, but in the next time when you open it again, maybe next day or maybe later, same on the same day, it will open very fast. How it happens? That it actually uses this cache memory. So cache memory, what does is, whatever data you have recently used or something, that would be the one copy of the data would also be stored in the cache memory. So before going to the database, it will first go to the cache memory, and cache memory is faster than the database, actually, guys. Okay, so if it gets the data from cache memory, so it would like send it to the client or the user without going to the database. Yes, temporary storage, where you can say, Sneha, yes. Okay, we have even our system, our laptop, our computer, it has a cache memory. So in a system, in a client, in our system, if I talk about a laptop or a computer system, cache memory is actually between your RAM and your processor, CPU. Okay, your CPU, if you don't have cache memory, what will happen? CPU will try to fetch data from RAM. If it is not in RAM, then it will find data in the hard disk, secondary memory. Yes, Sujit, I'll come to it. I'll again come back to 3 tier. Sujit, 3 tier is nothing, but let's say the server itself cannot hold the data and logic, all the data and logic, because server is also a piece of code running on a machine, so it has its own limitation. Okay, so it cannot store all the data and logic every time. If the data is very used, if the logic is very large, it cannot hold every time. That's why they split up. This service, this logic, this application is separate, and the data is separate. Data, you can say, that is stored in a database, so we need to fetch data from a database, and this service application would be there, where it will fetch the data from the database, and it will do some computation and return to the user. This is 3 tier architecture. In n tier, what happens is, when your system is very large, and it has a very large user base. So we don't want to we want to make the process bit faster. So we can have this cache memory between this database and the application, our service application, so that some recent data which were used, though that would be stored in the cache memory, we don't have to always request the database for the data. I can go to the service, this application, go to cache memory and retrieve the stored data, temporal data, the temporary, in the temporary storage you can say cache, the data would be stored, the data it can fetch, and it would be faster. Okay. No, Manish, see, he can say 4 tier. I'm just giving n tier. There will be like there will be many such component can be added. So I'm saying n tier. Okay, I'll be adding one more also component to this. Just wait for it. I'll be adding one more component. Yeah. Okay. So I think we understood cache memory in a system, in a laptop, in a computer. We have cache memory which sits between our RAM and CPU. So just to make the data fetch faster. Okay. Yeah. RAM is, see guys, if you go for the speed of the memory devices, register CPU, the CPU register is the fastest, but it is very much costly and the memory is limited. Then cache memory is faster. After cache, RAM, speed. Okay, I'm actually mentioning in terms of speed, in decreasing speed. So first CPU register is the fastest, then cache memory, then RAM, then your hard disk, secondary memory. This is about this system or laptop or computer, whatever. But when you go for an application, when we're actually talking about your client and client server architecture, when we're actually in the internet, we are on the internet and we are sending some request to server which is stored somewhere else and it is giving back me data, fetching from database and all. So then your disk becomes a cache. Your disk, your memory, your system memory becomes a cache memory for in the network, in the internet, so that it would first check the data stored in your system rather than requesting over the internet, rather than requesting over the network, because obviously if it goes to request over the network, it will take some time for the data to pass, to signal, for the signals to pass. That is quite obvious. Okay, so cache is used for faster data reading purpose, you can say fetching data purpose. That's what cache memory. I hope I'm clear with that. Now let's see services. We now have, let's say we had only one client, so it actually just asks the service application and it just send the data. But what happens, I have, let's say 10k clients, 10k users requesting something to this application, to this service. Then what would happen? Will this service be able to serve this? Can it accept the request? Can it serve the request of every client at the same time? Let's say 10,000 clients are there and they are requesting something at the same time to this service. Your server will crash, your application, this particular service or application will crash. Obviously it cannot handle so many requests at the same time. That's where come another component, guys, and very important component, that is load balancer. So here in between the clients and this service, my bad, okay, let it be here, it comes load balancer. I think it's very intuitive by the name itself. We can understand by the name itself what is this load balancer. So load balancer is nothing but if there are multiple clients and they're requesting, okay, if they are requesting something, so load balancer will balance the load to the service. Okay, right? That is what is the task of load balancer here. But again, if your service, if there is only one instance of the service, sorry, if there is only one instance of the service, that will not make a bigger deal. So there should be multiple instances of the service. See guys, let's say just take this example of your college canteen. If let's say there is only one counter from where you can get food in the canteen, So obviously you would be annoyed, right? You will just move away and go outside the college and have something okay, right? But if let's say there are multiple counter, 5 counters, so so you can go to this, like some people go to first counter, then some people will go to second counter, some people will go to third counter. So the load, the requests are distributed, right? So there are 100 peoples and only let's say there is only one counter, so obviously everyone would be online, and maybe the last 50 students, they will just move away, they will just go back, go somewhere else. That from the business person, as a business person, I won't like that, I won't like want my customer to move away because of this. So what I'll do, I'll just create 5 counters, so that those 100 students, 20 people can go to each of the counter and will get get the whatever they want, whatever food they want. Okay, so what I have done, I have distributed the load on my system, I have distributed the request on my system. Okay, that is the task of load the like okay, fine, that is not the task of load balancer. That is where we understand that actually we need uh, multiple instances of a particular service if we want to serve many people at once. If you want to, like, yeah, if you want to serve many people, so we'll have a multiple instances. Okay, how would we send to back? Yeah, so this way I can show you that okay, there are multiple instances actually. Okay, right, this way I show there are multiple instances, so you don't have to create so many blocks there, just like create 1 or 2 blocks behind it, so that would say that okay, there are multiple instances of this service. So what load balancer will do here, load balancer has a task of distributing the request. Okay, distributing, like let's say yeah, let's go to the same example. I have, like, you go to the college canteen, I am the canteen manager, or maybe I'm the canteen, what do you say, supervisor. So there are 5 counter, but what student will do, all the student will move to the that one counter. Okay, because their friend is standing over there at that counter, so everyone will go to that one counter, maybe 2 counters, these 3 counters are left, like is free, there is no one, but all of them are actually putting the load on the 2 counters. I won't like to have that, right? I have created 5 thing, I want to reduce the load in each counter person, so there would be a person behind the counter, right? So obviously there would be more load on him or her. So what I'll do, I'll make a person stand there, and I'll make him, like, what that person will do, the person will say okay, you go that counter, you go this counter, you go to that counter. I think some of you might have seen in a petrol pump also, they also do. Okay, this, so that person actually does the job of load balancer. Okay, whenever requests come from multiple client, this load balancer will distribute what is that, the request among these various instances of the service. That is the task of load balancer, so that all the requests would not be put on a single instance and make it crash. So if the requests are distributed properly among the services, then your system would not crash and you would be able to provide service to all the requests. Understood, guys? This, it's not a rocket science, not mathematics, nothing. It's just like common thing which we do in real life. Understood, guys? Those who have actually seen this AWS or GCP, you might have heard instances. What is this instances? Instance is nothing but a replica, you can say. Various instances of the service is running, and load balancer would be there, which would distribute the loads equally, distribute uniformly between those instances, so that all the load will not be sent to a particular instance and make it crash. That's what the job of load balancer. There is this traffic, and I think I have noted down a few load balancer names. I'm not sure whether I have written it or not. Anyway, fine, you can search it, guys, the various load balancer names. I remember this traffic is there, maybe HF proxy is there also, load balancer. Yeah, everyone, load balancer. Okay, So this is an example of entire architecture. You can also have other component guys, but I'm not getting into those stuff right now. Let's now move on to one more thing. We have successfully covered till now client server architecture. We have covered thick, thin client. We have discussed about this one tier, two tier, three tier, and we have discussed briefly this load balancing. I'll be covering load balance, the strategies strategies followed by load balancing in a short while. But before that, I just want to cover one more thing, guys. That is proxies. Okay, proxy. I think all of us talk about proxy server, proxy address. What exactly is that proxy? Let's try to understand what is proxy. Okay, fine. So I have this. Uh, okay. I'm creating this so many blocks just to show that okay I have so many clients actually. Okay, right? And then there will be so many servers also, right? Maybe this we have, let's say, four instances of the server. We are talking about client server architecture, so there are four instances of the server and four instances of client. Let's say, for example, you can all do the aligning part. Okay, fine. Okay, I'll just create a thin line here. Where I'll get. Hmm, okay, so I'll say this is client side and this is server side. This is client side, right? And here this is server side. Okay, there are four instances of server and there are four instances of client. I'm just representing, guys. There can be 40 clients, 40 servers, maybe 4 million client and 4,000 server. Obviously the number of client would be more than servers. Okay, that is for sure. Obviously we cannot have that many number of server instances as the number of clients, obviously, because that would be cost like very expensive. Obviously if we go for creating so many servers, then obviously we'll have to pay more. Okay, we can't really afford that. So we need a mechanism so that even if we have maybe 1,000 client, we should be able to handle it through 4 servers or maybe 5 servers. That depends on like how many instances you can create on your capability. What is your capability? That is different thing. So I have a client here. I want to send here some request the server for something. Fine, and we now know there would be here. There would be a what is that? Okay, here there would be this load balancer in between this server. Okay, we know this. So let me also create one more shape here. Okay, this would do. So I'm creating here something. It is my load balancer, right? Load balancer, load balancer. Fine, this is my load balancer. Similarly, guys, here on the client side, there might be something. Where is it? Yeah. Okay, fine. I think I've done it. So here I can say that this is actually a proxy. So what is actually a proxy? Can anyone say what is proxy? What is proxy, guys? What is proxy? What is proxy? I think we have all like maybe all of us might have heard this term: proxy server, proxy address of a particular thing. Proxy. See, there are two kinds of proxies. There are two kinds of proxies. I'll just write here. One is forward proxy. Okay, right? I'll keep it here. Forward proxy, and another is reverse proxy. Okay, forward proxy and reverse proxy. Forward proxy is on the client side and reverse proxy is on the server side. Okay, see this. What forward? Let's discuss this forward proxy first. What forward proxy does? Proxy server, this proxy, forward proxy masks your identity. Okay, maybe this client is okay. I should not be doing this. Maybe in short shape. Yes, this is fine. I'll be going for this way. This particular client is actually, let's say, um, what is that? Like requesting something. But the thing is, it will not actually request directly to the server. The request will go through the, if you have a proxy, let's say you are in a company, guys. So normally these companies and organizations set up this proxy server actually. Okay, whatever client request to the internet, to the server, it will go through that proxy. Okay, and when it goes through that, when it goes through the proxy, then obviously this proxy, what the proxy will do. What do you mean by proxy basically? Proxy is nothing but it is actually requesting the server on behalf of that client, right? On behalf of the client. So what this server will understand that, okay, maybe this proxy has some IP address. Okay, I'm not actually going to the IP address. This client IP address will be different. This proxy IP address will be different. Server will think, okay, I'm getting some request from this IP address of proxy. Okay, I think we should write something here. What should I write? Okay, for example, it's not very intuitive, it's not very good. I should go for this AAB, but let's say for example my IP address is B. Okay, my IP address is B, and IP address for this client is, let's say, A. I know IP address doesn't look like A and B. It is something like 192.168 something, or maybe 41 dot something kind of that way IP addresses are there. But let's for the sake of understanding it, the IP address of client is A and IP address of proxy is B. And so client whose IP address is A is requesting something to the server, but the request would be would go through the proxy. So for the server, actually it is getting request from IP address B and not A. So it has masked your identity. Okay, it had masked your identity. So now the client IP address is different from the server side. Or the server, actually it is now getting request from B, IP address B and not A, but actually the request is sent by A. So it is actually masking your identity from the server. Okay, it is acting as a proxy, like you also put you might have done, I'm not sure whether you have done this or not. In colleges, what we do, we put proxy attendance for our friend. So what you are doing, you're just putting attendance on behalf of your friend, right? Okay, so basically it's exactly the same thing. Here on behalf of the client, this proxy is actually requesting the server. Okay, the proxy is actually requesting the server. Am I clear up to this, guys? Can anyone please confirm in the chat? Can anyone please confirm in the chat? Or am I stuck or something? I'm clearly audible to everyone. Yes? No? Example. Yes, Priyanka. Yes, example is attendance, proxy attendance. You put proxy attendance for your friend in the class. So that's actually proxy, how the proxy is working. Okay, so proxy basically masks your identity, your system identity, your IP address from server thinks, okay, the request is coming from some other system, not your system. Okay, so proxy has various usages in companies, in organization. Why do they put proxies is, yes, it hides our IP address. So they also they set up this proxy server proxies in order to block some websites. Let's say they don't want you to go to YouTube, in your company, in your organization, while you are working in the working hours in the company, while you are working in the company, they don't want you to watch YouTube. So what they will do, they will set up this proxy thing and they'll block the YouTube. Okay, they'll block the YouTube actually, so you cannot actually it will block you. So actually basically the rerouting is happening here. Okay, the client, the HTTP request actually going to proxy, so they will block it there in the proxy server, so that request will not go further, right? So that's what your proxy. My question here is to all of you guys, that is actually an assignment. You have to submit this assignment in, if you want to get your completion certificate. What is the difference between this VPN and proxy? A lot of people actually get confused. They say VPN and proxy are actually the same, but it is not actually. So you have to submit the answer of what is the difference between VPN and proxy. Even VPN hides your identity, right? It hides your IP addresses, but what exactly the difference is? Okay, so proxy is something which is acting on the behalf of the client. Okay, client is actually requesting something, but on behalf of the client, the proxy is now requesting the server. So for the server doesn't know the client, it only knows the proxy is the client for it, but actually the proxy is different. Okay, so just give write down the answer, okay, and submit it. Got it? So what exactly is VPN? What exactly VPN is? The difference between VPN and proxy. Okay, right? And which one, if we want our privacy a lot, we are very strict about privacy, let's say, which one we would go for, a VPN or proxy? Because both masks our identity, both hides our IP addresses. Okay, just research about it, submit the answer. Okay, this would be assignment for this day. Second question is also, that is also an assignment. Can a server act as a client? Okay, can a server act as a client? That is a like secondary question. Submit Sadiq. If I'm sorry if I have pronounced your name wrong. You can see the description of this video. There would be something called assignment submission link or something. Basically, that is a link to a YouTube video. There we have actually explained how you can submit your assignment. So you should register for the course first of all. Then you can actually see the you can access the LMS, our LMS, and you can put the assignment over there. Okay, or else what we can do is, okay, wait, you don't have to do all those stuff. What I'll do is, I'll just create directly right now. I'll create a form and I will share a link to all of you. Umang, can you also pin that for me, maybe for within for the rest of the time? Attendance link, they have, I guess already fetched this, and they can also fetch it from the description. So I would be creating a form right now, and all of you guys submit your answers there. Okay, so just give me a moment. I'll just create it very soon. I just need a moment to create it. Just a moment, I'm creating it. So what I'll do is, I will create a form here, and I will put just two options. I'll be giving you a option, draw, like we have only 2 days, right? Day 1 and day 2. You select day 1 and submit the answers. Tomorrow on the same form, guys, what you have to do is, you have to select day 2 and submit the assignment. So I'm just creating quickly a form for all of you. Just give me a moment. So the name of the form would be SD, System Design Assignment Submission. Okay, right? So first would be your maybe name, and this form will also collect your email addresses, definitely, right? Okay, okay, fine. So it will collect your name, which is mandatory, email is mandatory, and then you have to select the day 1 or day 2. Session, select session, I'll just say select. I guess you are not able to see what I'm doing it. Anyway, I think this is fine. So option 1 is day 1 and option 2 is day 2. Fine. Just have to select day 1 for today's. Uh, um, and what you can do is you can submit a document, like you upload a file, guys. Okay, I'll see it. Okay, so upload a file. Yes, you can upload a file over here, or it would be you can upload a file, that would be better. So you can submit a document or maybe PDF, your wish. That is a completely it completely depends on you. Either you can upload a document or you can upload a PDF. Number of files obviously one, yes, required. That's it. That would be your form. I'm actually sharing this link all of you over the chat. Maybe Umang, you can pin it for me. Later we would shorten the form link, guys, and put in the, you can also check the link later in the same video in the description of this video. Maybe after 1 hour, if you come back, you can see the form link would be shortened. Okay, so it is actually assignment submission form. Yeah, this look very huge. Can you please okay, I'll replace. Yeah, so it has been pinned, I guess. Not yet. Oh, it's not yet pinned. I'll do it again. No, it's pinned. Yes, now it is pinned, guys. So you can check out the pinned message in the chat, guys. Also, I have shared in the chat. So you just have to go to this form after the class, and you can submit your document or PDF by writing down the answer. Two questions. One is, what is the difference? Excuse me. What is the difference between VPN and proxy? Second one is the what is that? Can a server act as a client? Okay. If you check maybe half an hour or 1 hour later in the same video description, I'll put a shortened version of this link in the video description. Also, you can fetch it later. If you want to store this link right now, you can copy it and save it somewhere. Okay, it's pinned already. So also it would be put in the description, it would be updated in the description maybe half an hour or 1 hour later. Okay, right? And yeah, materials and all would be uploaded in the community, guys. Even the also the community link, the community group link is also mentioned in the description. You can also check out that. But I was looking forward to cover some more things actually. Yeah, this load balancers, I wanted to discuss something more about. I think we can discuss something more, some more time. We can take some more time and discuss. I think this is interesting, whatever we are doing now. Is it interesting, guys? Is it interesting? Yes, Arijit, even the assignment question and materials would be posted in the community group. Okay, community group link is mentioned in the description box. Okay, right? Just after the session, maybe 1 hour. Okay, after completion of the session, maybe within 1 hour, assignment and both materials would be updated in the community group. You can fetch the assignment question from there, and this link which is pinned right now, also this link would be put in the description half an hour, or yeah, assignment form is also put in the description right now. Thank you, Umang, for that. She has added that in the description right now. Maybe later on you would have a shortened version of this form link. Also put there, guys, submit there. It's interesting. So yep, thank you. Let's take some more time and discuss some more interesting concept about it. I was talking about this load balancing. So how exactly this load balancer works? Okay, right? If you're not, if you cannot keep a track of the question assignment, don't worry, guys. In the community group, we would post both assignment and this material, which whatever I'm editing and creating stuffs. Yeah. So next thing which I am going to do is, we are talking about how this load balancing works, or simply to put forward the strategies of load balancers. Load balancers. Yeah. Okay. What are the different strategies? There are various strategies, guys. Okay, but I just want to discuss the most important and the mostly used strategy, that is a very common name, very popular name, that is round robin algorithm, round robin strategy. Okay, how many of you know this, guys? Put in the chat. Maybe you can say, you can put this symbol in the chat. Okay, just put this symbol, everyone, those who know what round robin is. What round robin is, I think you might have studied this in operating system subject, those who had this subject. Okay, otherwise this is also a very common topic actually. Round robin, who knows this round robin? So one of the important algorithm or strategy that is used by load balancers is round robin. There are other strategies also, which I would just name it later. Let's finish up this round robin first. So round robin, what round robin says, guys. So I'll just quickly move back to this one. Yeah. Okay. So before moving back to this round robin, moving forward to round robin, also I want to make a point here. See, this proxy which we have at the client side, this is forward proxy. Okay, and this proxy which we have on the server side, load balancer is also a proxy, guys. Okay, actually we are requesting to the server, but load balancer is fetching the data, like fetching the request, then it is distributing to any one instance of the server. For this, for this for now the client, let's say this proxy b is not what I'll do, it would be better if I, okay, so I'll delete this. I'll delete it. Okay. So even I delete it. Fine. So I am requesting now server. But what would happen? The request will go to the load balancer, and load balancer actually will request any particular server, maybe this. So for client now, load balancer is a server, but actually it is not. It is actually acting as a proxy. Okay, on behalf of the server. So this load balancer is actually a reverse proxy. Okay, this is reverse proxy example, right? And forward proxy, you can say there is no load balancer, for example, and maybe directly the request will go to this one. This is forward proxy. I say forward proxy if we have the proxy on the client side, reverse proxy if we have proxy on the client server side, and this load balancer actually acting as a reverse proxy, because it is behaving as server for the clients in place of server. Okay, right? Yeah, so this load balancer, how this load balancer works, how it distributes the request to different instances of the server. So the most important is round robin. Round robin is very simple, as the name suggests, it is actually round and it will go in the round manner, guys. Okay, right? It's very simple. Let me just quickly say, I will not draw anything. I'll just say if I have a server 1, then I have let's say server, okay, server 2, then I have the, right, server 3, then I have server 4, let's say. These are the list of 4 servers we have. Means 4 instances of the server, not 4 servers exactly. 4 instances of the server are there. So round robin, what it does is, it will go in a loop manner. First a request comes, so it will go give to the server 1. It will distribute, it will give to a request to server 1. Next request comes, it will give to server 2. Next request comes, it will give to server 3. Next request comes, it will give to server 4. For the next request, it will again come back to server 1. So it will move in a round robin. This is called a round robin, in a loop. Server 1, server 2, server 3, server 4, again server 1, server 2, server 3, server 4, again server 1, server 2, server 3, server 4. This is called round robin, guys. Got it? Understood? Not yeah, first come first serve is also a strategy. Yes, definitely. There are various strategies. First come first serve, here in load balancing, let's not will not use. See, because see, there are instances. It's not like we have one instance, whatever request comes first we'll give it. Obviously that would happen. Okay, first come first serve is a strategy where we use in the cache. memory. I'll talk about that. Maybe today we won't be able to catch up that concept, and tomorrow in the next session I would talk about the strategies of the cache. Okay, caching. So there we'll come across this first come first serve. But right now, round robin is like, let's say first, so the request is given to server 1, next request would be given to server 2, next request would be given to server 3, next request would be given to server 4, again next request would be server 1, server 2, server 3, server 4, server 1, server 2, server 3, server 4. So round robin, in a circular manner, it would give request, it will distribute request. Okay, no, we're not talking about priority, preemptive, not at all. Those are, you're talking about the operating system processes and all. I'm not talking about synchronization. I'm not talking about the process preemption and all. I'm just talking about how load balancer works right now. Round robin, it just, if it gives request to one server, next request will be given to the next request would be given to the next, and the next moment it will just circular, in a circular manner it will go on distributing the request. That is round robin. Okay, understood round robin, everyone? Is it clear, the round robin? It's very simple, very simple. Okay, clear everyone, round robin. Round robin, not every time it would be efficient, guys. It's the most popular thing to be used, but obviously it won't be always efficient. Why so? Because not every request are equally or you can say not every request is putting equal amount of load on the server. Different request will put different amount of load. One request may be putting very less amount of load, one request may be putting very heavy amount of load. Okay, so the number of load would be different for different requests actually. Okay, this round robin may not be very efficient in all the cases. That is why we also use other strategies, like um, there are load based strategies actually. Okay, load based means we know that, okay, already server 1, instance 1 of server. Okay, I'll just move here. Okay, server 1 is having 10 requests right now, let's say, and server 2 is having, let's say, 5 requests right now, and server 3 is having, let's say, 7 requests right now, and server 4 is having, let's say, 3 requests right now. Okay, so load based strategy, what in that strategy what would be done is, okay, yeah, what would be done is, it will distribute the next request to the server instance which is having less load, less number of requests, which is serving less number of requests. That is actually what is that, load based strategy. There are other strategies also, guys. Okay, but mostly commonly used is round robin, and this is also one of the good strategy, the load based distribution strategy. Okay, depending on how many requests a server instance is actually handling right now, we would try to give the request onto a server instance which is actually having less requests right now. We don't want to overload a like in round robin, what may happen is a particular instance might be serving so many requests, and there will be some server that might be requesting only less few requests, might be serving very few requests. We don't want that. We want to uniformly distribute the load also. So load based strategy also we can use. There are other strategies also. Okay, like resource based. Okay, okay, fine. Resource based is also there. You can go for that. Like if a particular server, has a particular resource that you want, obviously that load balancer will direct your request to that particular server, because that server has that resource that you want. Okay, this is you can say resource based strategy, but most importantly you should know this round robin. Also, if you want, you can go for this load based strategy. Okay, list connection. Okay, fine. So that is a brief idea about load balancer that was on my list, which I had to cover. So I have just framed a sequence, guys. That is load balancer. And the last thing which I want to discuss today is, and I'll just take maybe 5 more minutes, and I'll close this session off. I don't want to overload. I don't want to put so much of request on your system so that you won't get overloaded, guys. This system, I'm talking about this system. I don't want to put so many requests there, right? So many write requests there. So I don't want to make your system overload. Okay, well, I'll stop by just discussing one more thing, that is CDN. Okay, you might have heard about this. CDN. 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 What is the CDN? Content delivery network. Yeah, if I'm correct. If I don't, we don't usually use a long term here, like full form of the abbreviation. Normally we say CDN. Might be wrong. You can check it out. Content delivery network, CDN. So what is a CDN is actually, and why do we use this CDN, guys? Okay. See, I'll just give a very simple example. We are here in India. I'm streaming this, and we are providing some courses here in India. There might be someone who is watching from yes, the person who is watching from Nepal. It's fine. They are in a close proximity with India. They are very near to India. But let's say a person is watching our session in US. Okay, obviously the uh, that person would actually see the content much later as compared to you. You being in India, you would watch the content first, like sooner than that person sitting in US and watching the session. Because guys, data are getting transferred, right? Data are getting transferred. So signal, the farther you go, signal will take more time to travel. Okay, Aman. Okay, well, I cannot commit right now, Aman, but we'll surely try for it. Okay, okay, Shai, it's already overloaded. Okay, just one thing. This CDN. Let me just finish this CDN. I had planned to cover protocols today and casing strategies, but I see I cannot cover it today. Yeah, I'll cover it that next time. But just give me the CDN. We'll complete the CDN. Just 2 more minutes. Okay. So it's a very simple case where we are now sitting in India. We are streaming this system design course. You being in India, you can actually watch the course sooner. Okay, see, I'm streaming at a different time, and you are watching the session maybe 10 or 20 seconds later, because that data transfer is will take some time. That from my system, it will go to the YouTube server, and then YouTube actually displays you to you the content. You are requesting YouTube server, the YouTube is requesting me. Okay, my system is giving data to YouTube, and YouTube is actually serving you, right? Okay, so this time, this data would data travel time, that counts. So now it is maybe 10 to 20 second delay, but imagine you are in US. Obviously that delay would be more, then the delay would be more, because the signal would take, yeah, latency, yes, obviously, yes, exactly, latency. So latency would be more, obviously, because the distance is now more, the signal has to travel more distance now. Okay, that is where the CDN comes into picture, guys. Okay, what is the other solution? What you can do is, why this delay is happening? Because the server is in India, let's say Mumbai, our head office is in Mumbai, the server is in Mumbai. That is why, let's say, um, from Mumbai to US, it is taking more time. So one more alternate solution is, you will also set up one more server in US. Okay, you will also put one more server in US. Then okay, Australia people will say, okay, they are getting late, so you'll put one more server in US, Australia. They will also watch the content sooner, like in less, the latency would be less, in short, latency would be less. But it is very expensive to set up these servers at so many places. We cannot afford that. So CDN comes into picture, guys. Your server, let it be in India, your server is at the specified place, at the one place. CDN will actually create you can say a static storage at various places across the across the globe. The CDN will act as a storage of your static content. What is static content? Maybe image, maybe, let's say, when you go to www.letsupgrade.in, that logo has to be downloaded. It will take some memory space, it will need to be downloaded. That data, if I am in US and I'm trying to fetch it from India, Mumbai, that transfer will take more time. But CDN, what it does is acts as a kind of storage. Okay, storage actually. It stores the data. It's actually have copy of those static files. And in US now I have a CDN in US. I request that file. So from CDN I'll get it. So obviously the process will be faster. This is CDN, content delivery network, nothing much. So basically guys, we are done with today's session. So I hope you enjoyed today's session. And there is something new, I hope I could able to impart, and it was very fruitful session. I hope. Okay. Next, tomorrow I'm planning to cover something. I had planned to cover it today, but I could not. I'll go to caching. Okay. Briefly, I'll explain some caching. I'll cover protocols. I'll discuss some protocols which we need day to day life, and then I'll try to an important thing which we'll cover, that is queue. Okay, queue, that is very important. We'll discuss queue. I'll try to do a project. Okay, we'll try to build I'm not very sure the time should permit, but I'll try to build this Uber system design. Okay. And yeah, why I picked up Uber, also we are coming up with Uber API building, like Uber API building session coming forward. That's why but we had exclusive access to only to the student who actually referred people. But anyway, so I will go for this Uber system design if time permits. Otherwise I'll just cover this components which are used in the system design while we go for system. Okay, so that's it guys for this session. I hope you enjoyed the session. Let's meet again tomorrow at the same time, 7 p.m. and I hope you all see the community group maybe after 1 hour, and you find the assignment question and materials there. And I hope all of you submit your assignment in the given form link to just to get the completion certificate. It's a yeah, 3-day session. 2 day would be the topic I'll be discussing about system design. The third day, day 3, is basically a career and placement session. Okay, where we would actually guide you how can you prepare for your placement, what all you should maintain. Okay, yes Hardik, yes, for that actually I'm planning for actually going for a Uber system design. Let's see if time permits, we'll do that. Okay, maybe I would need some more extra time. If you are interested, would be interested, then I can take extra time and we will do that. Okay, right? Okay guys, so that's it for today. I hope I could meet your expectation. So thank you everyone, and we'll meet next day tomorrow at the same time. We'll discuss some more concept of system design. Till then, tata and bye bye and take care. Good night everyone. Good night everyone. So what I'll do, I'll just for you just to not exactly go out of the hangover, I'll just put a nice song for all of you. Not song, maybe a music bit or something. I'll just put here for all of you, and you can just hum to it for some time, and I'll just end the stream afterwards. Okay, right? So where is that? Where is that? Where is that? My music is there. Yes, I have that music. It's basically the same music which we had, right? Okay, fine then. Fine then. Just a moment. Yeah, I'm done. Okay. Yeah, let's end this session guys. Thank you everyone. Thank you for being here. And yep, I enjoyed this session very much. Thank you all for joining. Let's meet tomorrow. Bye bye guys. Good night.